In this video, we will explore the measurements of small field output factors in a varying true beam equipped with HDMLC. These HDMLCs have least widths of 0.25 cm in the inner part and 0.5 cm in outer MLCs. For this virtual prac, we will be using PTW Beam Scan Tank equipped with software version 4.4. The detectors that will be used in this experiment is the PTW Cylindrical Waterproof Ion Chamber Semiflex 3D and the PTW Microdiamond. To start, the tank was positioned under the linac using the lasers and a light field crosshairs as a guide. These will roughly position the tank as close to the linac isocenter as possible, and fine adjustments are made in the following steps. Once the tank is roughly in place, the drive mechanisms are zeroed under the crosswire and the Z height of the drive mechanism is set up using the optical distance indicator to the isocenter. The water tank is then filled up to the water level indicated by the Z height using the onboard water sensor. To level the tank, manual leveling mechanisms can be used to ensure the drive mechanism is parallel to the water surface. In this practical, we did not use the manual mechanisms. As shown in this video, a water sensor will detect the water surface in 3 points to establish the plane of the water surface. The drive mechanism in the in-plane and cross-plane profiles are then assumed to be level to the water surface from this point on. Two identical cylindrical ion chambers are connected, one as a field instrument and the other as a reference. The cylindrical ion chamber is 4.8 mm diameter and 4.8 mm long, and the field instrument is mounted axially. Once the detectors are submerged, the height of the water tank is reset to 100 cm SSC using the front pointer. The tank is then fine-tuned to the radiation beam using the auto setup function. Firstly, the tank will automatically scan an in-plane and a cross-plane profile at the user-specified field size and depth. In this situation, the field size chosen was 10 by 10 at a depth of 3. An additional 2 profiles were taken at the field edges to determine the rotation of the tank with respect to the beam collimators. For small field output factor measurements, the detector was swapped out for a microdiamond and connected to an external electrometer. The output factor was measured at 100 cm SSD at 10 cm depth. The jaw sizes were set at 4 by 4 cm squared, and the MLCs were defining the fields. The MLC field sizes range from 2 by 2, 1 by 1, 1.5 by 1.5, and 0.5 by 0.5. This process was then repeated all over again with PTW Diode E. Now the data is handed over to you to cross-check and analyze. What are the differences between these two detectors? Which values are correct? What field sizes would you use for your reference?